Hello, everyone. Hope you're having a good day. We're going to go through a little lesson here. As you can see, the title 5.1, Fundamental Trig Identities. That word identity, another word for it would be maybe a rule or a formula, a fact. We're gonna kind of go through today the different identities dealing here with trig that we are going to use for the future. And this is a pretty important section that we're going to start here. We're going to use these identities, and they're things you're going to need to know, kind of from memory at some point in the future for a lot of different things. The first thing we're going to do, you're going to see today, is we simplify some trig expressions. In the future, we're going to do something called verifying an identity. And finally, we'll use these things to do some equations and solving equations. Basically, what we're going to go through is kind of go through the different identities, many of which you kind of already know, all right? Maybe just not in the format you're going to see here. You need to write these down. If you have a piece of paper, that's fine. I also posted a kind of blank sheet that I use as an identity sheet that you could fill in, or I may have given it to you in class as well, all right? The first thing is, I know some people get a little confused at all these. You can see sine u, cosine u, tangent u. U is just like theta, an angle A or B or C. It's just a variable we use for the angle. Okay, it doesn't really matter here. The first set of identities are called the reciprocal identities, and like I said, these you kind of already know. And I'm actually going to start with the cosecant one. For example, cosecant is equal to the reciprocal of sine, which we write as 1 over sine of u. That's a reciprocal. Okay. And secant, of course, we know is 1 over cosine u. And cotangent would be 1 over tangent u. All right, so they're reciprocals. Now, how we're going to use these in a little bit, you'll see, is we're going to substitute. So we may change a cosecant that we see in our expression to 1 over sine. All right, we might replace it, substitute it in. All right, and there's reasons why we want to do that, and we'll see. What we don't normally think of as the other three are actually reciprocals of those ones. And for example, sine is actually the reciprocal of cosecant. We haven't really used it that way, but we may use it that way sometimes. Cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. So this is an example of what I mean. We kind of already knew this. We just didn't know it written out like this. We knew cosecant's a reciprocal sine. That's why I kind of have you learn it that way, so it applies in the future as well. Quotient identities, this you might kind of already know in a certain way if you think about it. Quotient means division, so these are all fractions. And what the quotient identity is, tangent is equal to sine of u over cosine of u. Sine over cosine. Think about that a little bit. Let's think about our unit circle. I know it's been a little bit of time, but tangent is y over x. And what is y on the unit circle? Well, it's sine. And what is x? It is cosine. Okay. And, reciprocal wise, cotangent's a reciprocal tangent, so it makes sense that it is cosine over sine. Okay. All right. So those are the first sets of identities that we're going to use and need. All right. Nothing to write here. I just want to reference you back to the unit circle. And to be honest, some of this, because of some of the things we missed due to COVID and last year in Algebra 2, might not make as much sense. But there is an algebra equation for a circle. And the unit circle in particular, like the normal equation, the standard form is this of a circle. I'm not sure you guys got to this last year in Algebra 2. Well, in our case, our center, that's what the HK represents as the center, is at the origin of 0, 0. So x minus 0 just is x squared plus, and k is 0, so that would be y squared. And it has a radius, this circle has a radius of 1. So 1 squared is 1. All right, so that's the equation of that circle. Now, why I'm bringing that up, we're going to come up with a new identity here, and we got to remember on the circle, cosine is equal to x, sine, should put a u next to that, is equal to y. So if we kind of plug those in, we would get, now I'm going to show you something here. We get this, right? Sine squared, oops, put that in for the wrong one. Let's try that again. cosine squared plus sine squared equals 1. Now this becomes an identity, but there's a little notational stuff here that we need. When you square this thing here, when you square a trig, we don't normally write it like this. We can with parentheses, that's fine, but if we drop the parentheses, that would be confusing. It would look like the u is squared. So the way we write squared, trig, or cubed is we put the square there in between the cosine and the u, and we put the squared there. Okay? So that becomes an identity. All right, and we call it, oops, let me scroll that better. We call it a Pythagorean identity because it's, kind of like a squared plus b squared equals c squared. All right, so that is an important identity that we need. Now, there are what we call variations of this identity. So we're going to spend a lot of time. If you look on that sheet I provided, there's a little bit of blank space. All right, so I'm going to go over a couple different variations. One variation is I can solve this for cosine. Okay. So in other words, how would I get cosine by itself? Well, cosine squared, I should say. Well, you would subtract both sides by sine squared. So you get 1 minus sine squared. So that's one variation. That's an important variation. Conversely, we could do the other one. We could solve for sine squared. And we get 1 minus cosine squared. So that's another variation. Really, you don't need any of the steps written down. You just need these things that I'm boxing or circling. Those are the variations that we need. So those three are pretty important. We're going to use often. Probably the last two more than the first. Now, there's a couple other variations that we use that sometimes are a little tricky for people to see. But I'm going to do something here. I'm going to take that original identity, cosine squared plus sine squared equals 1. And I'm going to divide everything by cosine squared. Well, cosine squared over cosine squared is going to give me 1. Now, if we apply some of the identities we just talked about, that we know up here that tangent is sine over cosine, and we know secant is 1 over cosine, we can use those identities to simplify this a little bit so that sine squared over cosine squared actually would be tangent squared. Okay, and cosine squared would be secant squared. So that is another variation that we use. Okay, so it kind of gives you an idea here too what we do with these identities. We use them to simplify things. So instead of having, that, we can change it to tangent squared. We can do the same thing. And again, I'm just trying to show you where these variations come from because you need them. We need to know them. If I divided everything by sine squared, okay. Cosine over sine is cotangent. Squared, it's the same thing. Plus sine squared over sine squared is 1. And then 1 over sine is cosecant, so cosecant squared. So there's another variation. All right. So these, what do we got there, 5? Yeah, 5 are variations right now. Now, there can be a few other variations that we'll see as we work through these things and we'll add to it. But we don't need to worry about that right now. All right, so a couple other identities here. These are ones, the next ones are not ones that I would require you to memorize. When I look at that sheet that you have, or you could have there are 5 boxes. The first 3 are the important ones, and they're the ones you're going to have to know from memory eventually. The next 2, I would give them to you if we ever use them. Okay. The next one's called cofunction identities. And again, this one we kind of knew a little bit about. This one is equal to cosine. The reason I say we know a little bit about it, when we graphed sine and cosine, they almost looked the same. They were just kind of out of phase. There was a phase shift between the two of them, and that phase shift is that pi over 2. All right, so that's why that exists. So this one is sine, tangent, pi over 2 minus minus u is cotangent. This one's tangent. This one's cosecant. And this one is secant. Again, when we use those, I'll give them to you. They look weird, and I know compared to the other ones because there's a pi over 2, but actually it makes it easier because if you see something that has sine of pi over 2 minus u, you can immediately change it to cosine. Like it actually does make it a little easier. Same is true with these next set. These are called the even odd functions, or identities, I should say, not functions, but identities. And they're ones that we don't use often, but when we do, I'll give them to you. So first one, sine of negative u is equal to negative sine of u. Cosecant is negative cosecant of u. In a sense, what happened on those two, it's like we took the negative that was inside and pulled it out. It just gets pulled out in front. Whereas with cosine of negative u is equal to cosine of u, and secant of negative u is equal to secant of u. Kind of relates to the unit circle. I'm not going to get into it. Just know that it is true. It's cosine and secant. If you take a negative angle, it's the same as the positive. It doesn't change. Tangent and cotangent work like sine and cosecant, so the negative gets pulled out in front. Okay. All right. So let's kind of get into what are we doing with this stuff. Okay, there's a couple things, like I said in the beginning. We're going to simplify trig expressions, which we're going to talk about today. We're going to verify, which we'll kind of see a little bit probably next week, but really we're going to get into it probably after Thanksgiving. And then the last thing is solving trig equations, which will probably not happen until we get closer to Christmas. Okay? All right. So you have all these formulas, these identities. And when we simplify, there's some, I guess we could say rules, but it's kind of more like guidance for you, just suggestions, because these can be tricky. You want to think about them as sometimes little mini puzzles at times. When you simplify a trig expression, you're going to use an identity to substitute for something. The hard part to know is to know what to substitute for. Okay, and with practice, you get better at that. By the way, you're taking notes here at any time. I should have mentioned earlier. Don't forget, you can just pause at any time. You don't have to continue on with me, so you can take your notes. Some other suggestions. Next one, it says anything squared, look to use a Pythagorean identity. So if you see like a sine squared or cosine squared, look at the Pythagorean identity section of your formula sheet, of your identity sheet, to try to substitute in. Next, this is a good suggestion to understand what you need to do, and that is change everything in terms of sine and cosine. Okay? If you can get things in terms of sines and cosine, then you can work with them. Truthfully, and when I say sine and cosine, really one or the other is best, but if you have both, sometimes you can work that out. And talking about that, really that's what we want to do in simplifying trig expression. If I can change everything to be the same trig identity, trig function, I can work with it like a variable. If they're all different, then it's like having more than one variable. So keep that in mind. You're not going to change everything, because if you change everything, then you're still going to have different trig identities or trig expressions, and you can't simplify, because the last step is, after you do some of the identity, is simplifying, and that's where the kind of algebra comes into play and finishing the solution. All right, so let's just look at a problem. All right, so I've got a few examples here. Oops, I went too far. First one. All right, is this one here. So we got sine, we have cosine squared minus sine. All right, we have to think about what is it we want to do here. All right, well, I have a sine, I got a cosine, I got a sine, but you notice there's a cosine squared. All right, that kind of clues me in that I have an identity, and I'm just going to write it instead of flipping back to the sheet because it's a bit of a pain. You have an identity that equals this. Okay. Now, why is that beneficial? Well, I'm going to change that to this. so that I have okay. Now everything is in terms of sine. Now I can work it out. Now one of the things I didn't say is we're simplifying. What our goal is with simplifying is get it down to one thing, meaning one trig, and that trig could have, exponents on it. It could be sine squared, cosine to the fourth, something like that. Or just one number, like 1 or 2, something like that, okay? That's what we're trying to do. Now, there's some cases where that's not the case, but we'll talk about those when we get to them, all right? All right, so then I have everything in terms of sine. There's no reason to use any other identities, and there really isn't any I could use. Like I know somebody went, well, I could change sine to 1 over cosecant. Well, that's not going to help me because then things are going to be different. Everything's the same. It's like having like variables. I can distribute now, so this becomes sine, then minus sine cubed, minus sine. Now, let's think algebraically what's going to happen. Well, the signs are going to cancel. And I'm going to have negative sines cubed. And that's my answer. We have simplified. The purpose of this is we've taken this expression and we've simplified it to that. Okay. It's out of context, but there's a reason. Reasons are, in solving equations, it's going to be much easier to solve this than it would be to solve that. Okay, so that's the idea. All right. So let's try a few more. Oh, something else I'm going to let you know. There will be an assignment when we're done here, but I will tell you that I'm doing problems that are a little bit harder than the ones that you're going to be assigned. I kind of wanted to show you some different things with this. The ones that are assigned, most of them are pretty easy one-step type problems. Okay, you just plug in something and things cancel. All right, so the next one we're going to try. Let's see. Well, change cosine squared. I could use that identity. Not sure why. Sometimes we start this and we're not sure what we're doing. Now that doesn't quite help us because not everything is sine, but I have an identity that says this. Oops, that's 1 over sine. So if I change all of those things, now everything is in terms of sine. So the better you get with your identities and understanding them, you'll start to see that right away, that I can turn everything in terms of sine. Okay. Common mistake with this problem is people will subtract that and that, the 1 over sines, and get 0. You can't do that. It's multiplication first, so we have to distribute. So 1 over sine times 1 is 1 over sine. 1 over sine times sine squared. This is 1 over sine squared over 1, so we get minus sine squared over sine minus 1 over sine. Again, everything's in terms of sine, so we can work things out. You should be able to see that this positive fraction and this negative fraction cancel, and all we're left is this middle, and we can reduce this. This is like saying, y squared over y. Well, that equals y, so sine squared over sine is going to be negative sine. So that's the answer. So again, we took this and we simplified it to that. Okay. All right. A couple more kind of challenging ones. And again, I've put ones in here that have more than one step because I want you to see a couple different things, but understand a lot of the ones I'm going to give you here today are mostly just kind of one-step simple ones. So don't overthink those ones. But I wanted to show you some different things here in one problem. It's a lot easier than doing like a bunch of problems. So here's a good example of something. We got a sine, we have a cotangent, and a cosine. And we have to change some stuff. And sometimes we get frozen here, and I'm going to talk about it more when we're in class. What I mean by frozen, we overthink it. We also get frozen because we want to be able to solve the whole problem in our head before we get started. And sometimes you can't. So just do something to get started. For example, I have an identity that says cotangent is cosine over sine. Okay? So Now, what good does that do? I don't know. Not everything is cosine, not everything is sine, but I do have cosines and sines. So we can maybe work some things out. All right, at least I've changed one of them. You don't have to change everything. So if you're stuck, at the very least, change everything in terms of sines and cosines. All right, well, I'm going to put this over 1. All right, I'm going to do some multiplying. I get sine plus, and then cosine squared over sine. All right, so now here's where your algebra comes in, and this is the part here. And like I said, the ones I'm going to give you tonight or today are not this difficult. All right, so the algebra that comes into play is this. I'll put this over 1, and I got to get common denominators. All right, well, the common denominator is sine. Okay, and we're almost done. We're about 2 steps away. Well, here's the thing. If this was a 1 in the bottom, now a sine, we multiplied the bottom by sine, we have to multiply the top by sine. So I get sine squared. And then add them together, fractions I add together. The denominator stays the same. And then we look at that and some of us might be confused. Well, this is an identity. If you look, that is equal to 1. So we get 1 over sine. To be honest, we could leave it like that, 1 over sine, or we could simplify into cosecant of u. All right. I'm going to stop it right there. I'm not going to do number 4 right now. I'm going to give you an assignment here. You'll see it when we're done with this posting. Okay. They are much easier. They are simple, kind of one-steppers, but I gave you a couple things so you can kind of see different things in different math. We're going to pick these up later after Thanksgiving and work on this a little bit more. It gets tricky. What's going to be really hard is the algebra part of it. All right. I hope you guys have a great day. If I didn't already, because you guys were testing, I hope you guys have a great and happy Thanksgiving. Make sure to eat lots of food and enjoy your time off. Take care.